we're going to be working on circuit 1 here as our kind of example for the video to start with. So this is a series parallel circuit or a combination circuit. So if we're looking at this, we've got our current flowing and it flows this way and it flows this way in one path. And then when it gets in here, it branches into two paths because it's a parallel circuit. And then it's going to branch back into that original flow and go back to our battery. So what we got to figure out for this is like basically everything. I mean, we've got voltage total, but it changes in a parallel circuit. So this is the information we're going to have to solve for. So we've got to solve for voltage. We have to solve for current, and we have to solve for resistance. And we have to do that at the following places: R1, R2, R3, a place we're going to call resistor equivalent 1, and R4. So we've got to solve in all of those spots. And then we'll say we also have to solve for totals for all of these. So I'm going to make a line right here, go out a little larger, line here. Oh, that's not very good. Should have just pasted the chart in. A line here, and then we got all that room for resistance. So I'm going to use this slide over and over again. So just what I know the total voltage is 12.5 volts. I know that resistor 4, since it's in series, is going to be 12 ohms. I know that resistor 5 is 5.5 ohms. I know that resistor 2 is 10 ohms. And I know that resistor 3 is 30 ohms. So this is my given information. Now I've got to do some stuff here. Like, for example, I want to turn this whole circuit into basically a series circuit with 3 resistors. So I want like 12 volts here, go around, I got resistor 1, go around, I'm going to have another resistor, and go around, I'm going to have another resistor. And this would be like R1, R4, and then resistor equivalent 1. Sometimes you have more resistors, so it'd be like a resistor equivalent 2 and 3. And that would be the combination of these two. So if we solve for this parallel circuit's resistance and add them up to get the total resistance, that is going to give us our answer here. So the total resistance of these two becomes resistance equivalent here. And with, resistor 1, resistor 4, and resistor equivalent, I can find out the current pretty easily. So I'm going to duplicate this and go to the next page where we're going to do that. Okay. So on this next page, I am just going to quickly erase what we've got going on here. So I'm going to erase that, and I'm going to solve for the resistor equivalent 1, which is going to equal, since it's a parallel circuit, it should really be 1 over resistance equivalent, but instead of doing the 1 over resistance equivalent, I always just rearrange it to being 1 divided by parentheses 1 over R2 in this case, plus 1 over R3. And I'm going to say resistor equivalent 1, EQ1 equals, and this should have been a Q1, 1 divided by 1 over 10 ohms plus 1 over 30 ohms. So I have to figure this part out first, which I will do with, not with that. I want to keep this up and my calculator. So 1 divided by 10, enter, plus 1 divided by 30. Enter. And we get an answer of resistor equivalent 1 equals 1 divided by 1.333 repeating, which is pretty easy to put in the calculator. So I got 1 divided by 0.13 many times. And that is going to give me a resistor equivalent at 1 of being 7.5, we're going to say. So my resistance here is 7.5 ohms. Good. Okay, so that would be like if I drew that circuit out now with the 12.5 volts and, the 5.5 ohms and going down. Now it would be basically a series circuit. I'll just draw around this. It would be a series circuit now that I could solve a bunch of stuff for. And 4 was 12 ohms. So I'm going to erase, or I'm not going to erase this, I'm going to duplicate this. So hold on here, duplicate, and I'm going to go there right now. So I'm duplicating this on the tablets while you can't see. So I'm actually going to erase this and redraw it. I wish I hadn't drawn it so poorly the first time, but it makes me feel less bad about erasing it. So here we go. So we want to do my circuit. Here's my battery, 12.5 volts. And then I got a nice resistor here, which looks really terrible. I'm going to try to do this one, at least get one decent. And another one over here. Okay, so I got my circuit right here. We got R1 is 5.5 ohms. Our equivalent one is 7.5 ohms. And R3 equals, or R4, I should say. I apologize. R4 is 12 ohms. Okay, so R total for this circuit equals R1 plus R2 plus, or R4, R1 plus R4 plus resistor equivalent 1, which R total is going to equal 5.5 plus 12 plus 7.5. And R total equals, and there might be some rounding here. Let's get the calculator up. 12 plus 5.5 plus 7.5 equals 25. And I'm always double checking how I did the rounding when I did it the first time around, but that is exactly what I got. 25 ohms. 25 ohms. Now, the great part about this is if we have any two values in a column, we should be able to figure out the third one. So I'm going to erase what I have here now, because you've seen me break it down. And now I can figure out the current total. So the current total equals the voltage total divided by R total. So the current total equals 12.5 divided by, did I put a point in there? That should be just 25. There we go. Divided by 25. So volts and ohms. So I'm going to do 12.5 divided by 25. And I am going to get a current total of 0.5 amps, which I think is pretty good. So 0.5 amps. And we know that in a series circuit, so these are the things in series. This is in series. And this is in series. The current total here would be like I1, and the current total here would be like I1 because it stays the same. The current total in here at like I2 and the current total here at I3 would have to add up to be I1, like Like if I were to write that out like I total equals I2 plus I3 in this case. So any one of the ones which equals I1. So like I1 and I total are the same. So anywhere in this I1 branches, I can just go right ahead and I can put the current in there. Ooh, need to switch my pen back. Okay, so the current total here is going to be 5 amps. The current total here is going to be 0.5 amps. And the resistance equivalent is adding these two together. So the current here would be 0.5 amps. Okay, so that's good. I'm going to duplicate this slide and continue moving. And yeah, you're going to have to duplicate slides to do all this work probably. So now we've got all our currents and we got all of our resistance and we got our voltage total. So we've got to start going in and finding the voltages at each resistor. And that's basically pretty easy to do. We're going to find first the voltage at R1, then the voltage at R equivalent 1, and then the voltage at R4. And after we get those voltages, we can find the voltage at R2 and R3. So the voltage at R1 is the basically the current at R1 times R1. And the current at resistor equivalent 1 times resistor equivalent 1. And the current at or the voltage at resistor 4 is the current at resistor 4 times resistor 4. Okay, and all those numbers are the same. They're all 0.5. And in fact, these two right here are going to be the same values. So that's going to save us a lot of time. Oh, wait, no, it's not. Disregard that comment. So to set this problem up, we got 0.5 amps times, and it's scooting a little down here, so I apologize for that, 5.5 ohms. On this one, we've got 0.5 amps times 7.5 ohms. 7.5 ohms. And on this one, we got 0.5 amps times 12 ohms. Okay, so that is terrific. So if I pull up my calculator here, I can punch those numbers in. 0.5 times 5.5 is going to give us a voltage of 2.75 volts. So that's one. For the equivalent resistance here, if we do 0.5 times 7.5, we get, that is not correct because I divided 0.5 times 7.5. We get 3.75 in there, 3.75. And then for resistor 4, it'd be 12 times 0.5. So we get 6 volts here. 6 volts. And that's going to add up to 12.5. So that's following Kirchhoff with the bad Hare's laws there. So now we need to figure out what the voltage at these two is. Now, keep in mind the voltage at these two is going to be the same as the voltage coming into these two. So the voltage coming into these two is 3.75. And since current does not change in a parallel circuit, since it stays consistent through it, that is what we're going to use there. So the voltage here is going to be 3.75 volts and 3.75 volts here. Which means the last thing we got to do is just figure out the current for these two branches. And to do that, we can use Ohm's law and use the resistance and the voltage total for that branch. So the current at R2 and the current at R3 equal the voltage at R2 divided by R2 and the current at R3 equals the voltage at R3 divided by R3. And if we continue that expression out, we can just fill in. So 3.75 volts and 3.75 volts divided by 10 and divided by 30. And I just have to punch those values in. So 3.75 divided by 10 is going to give me 0.375 amps, and 3.75 divided by 30 is going to give me 0.125 amps. And that is all the information we need for circuit 1. So I hope this was helpful. Good luck.